Okay, today we're talking about the Pythagorean theorem and its converse. The Pythagorean theorem states that in a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. So if you've got a right triangle, and if the triangle is triangle ABC, capital letters, then the sides opposite those vertices are the lowercase corresponding letters. So this would be a lowercase a, lowercase b, and a lowercase c. And the Pythagorean theorem says that for every right triangle, this leg A squared plus the other leg B squared is equal to the hypotenuse squared, c squared. The legs are the sides that form the right angle. The legs are the sides that form the right angle. A and B are the legs. C, across from the 90-degree angle, that's always the hypotenuse. Always the hypotenuse. So, if you're given the triangle, and you're given two sides, and one side's a 6 and one side's a 15, and you're asked to find the missing side length, it may have an x on it, it may have any variable you want, or you may see any variable over there. All right, so the legs are your A and your B. You can label them if you like, A and B. The hypotenuse is always side C, or X in this case. So you've got 6 squared plus 15 squared equals C squared or X squared. It doesn't matter which one you call it right now. So 6 squared plus 15 squared. You can do all that in your calculator. 6x squared plus 15x squared. That equals 261. So 261 equals C squared. Now, if you need this in radical form, which you may need it in simplest radical form, or you may need it in decimal form. My recommendation is that you put all your answers in simplest radical form first, and then decimal form. So you take 261 and you start dividing it by perfect squares. All right? I would 261 divided by 4 doesn't go. 261 divided by 9 goes. There, 9 goes 29 times. So if you square root both of these right here, you get the square root of 261 equal to C. Well, the square root of 261 is equal to the square root of 9 times the square root of 29. The square root of 9 is equal to 3. So 3 radical 29 is equal to C. And then I would take this 3 radical 29 and just, I say finish it. So 3 times 29 square root equals, and you get 1616. And if you just do that all the time, you'll get practice simplifying radicals, and you will start to recognize what a simplified radical looks like in decimal form. And you'll get more calculator practice. So put your answer in simplest radical form and decimal form. And set your calculator to second fix 2, and all your decimals will be 2 decimal, or all your answers will be 2 decimal places. All right, so then you'll see some problems where you've got to find one of the legs. So here you've got an x as a leg, and now you've got a 9 as the other leg, and a hypotenuse of 11. Label the sides. So your a squared plus 9 squared equals 11 squared. And now a little shortcut. This is a lot easier. In your calculator, you type 11x squared minus 9x squared. And it squares everything and subtracts it for you, and you're just left with a 40. You then find the square root of both sides. So a is equal to the square root of 40. The square root of 40 is equal to the square root of 4 times the square root of 10. And that simplifies to 2 radical 10. There's your answer in simplest radical form. And then if you multiply 2 times 10 and the square root button, 12.65. So there's your A or your X, or however the question is being asked. It's the missing leg. Anybody need to see another example? Make sure you label your legs A and B. It doesn't matter if you label them B and A. The side opposite the 90 always has to be C. Yes? 2 times square root of 10. You got a calculator? Which one? You got one of the TI 30XAs? You push 2 times 10 and then hit the square root button. Got to push equals. Did you get 12.65? You push 2 times 10 square root equals, I got 6.32 also, my bad. $6.32. When you push 2 and you push times, then you push 10 and you push the square root, and you glanced at your screen, that number that was on there was just the square root of 10. So until you hit equals, it hasn't multiplied it by the 2 yet. So make sure you hit equals. Good there? Okay. Pythagorean triples. A Pythagorean triple is a set of 3 non-zero whole numbers A, B, and C such that A squared plus B squared equals C squared. You can go on your phone and you can search Pythagorean triple, and you'll get a long list of numbers. All right, an example is 3, 4, and 5. Non-zero, 3 non-zero whole numbers. Non-zero whole numbers that make the Pythagorean theorem true. Okay? Up here, in this previous problem, we had a 9, and we had a 6.32, and we had an 11, right? And 9 squared plus 6.32 squared equals 11 squared. Agreed? Well, this 6.32 isn't a whole number, is it? Since it's not a whole number, those 3 numbers from the previous problem do not make up a Pythagorean triple. The 3 numbers have to be whole numbers. All right? They got to be whole numbers. 6, 8, and 10. Are a Pythagorean triple because 6 squared plus 8 squared equals 10 squared. There's a long list. 9, 12, 15. Pythagorean triple. 9 squared plus 12 squared equals 15 squared. So when you're asked about, or you're asked to use a Pythagorean triple to find x, your answers need to be whole numbers. All right? Answers need to be whole numbers. So if you're asked to use a Pythagorean triple to find x, all right, all the Pythagorean triple means is that the numbers all need to be whole numbers. Okay, so don't let it confuse you. So if you're given a triangle and we're using a Pythagorean triple to find x, and we've got x and 48 and 20, you're just doing the same thing you've been doing. You're taking 48 squared plus 20 squared and setting it equal to x squared. X squared plus 20 x squared 2704 is equal to x squared. If you square root both sides. Now, since you're using Pythagorean triples to find x, you don't have to simplify this 2704. It should be a perfect square, so you can hit the square root button on your calculator. So 52 is equal to x. The three sides are going to be whole numbers when you're working with a Pythagorean triple. Cannot have decimals. Okay. Let's see, what are we going to call this? Converse of the Pythagorean theorem, Pythagorean inequality theorems. Let's just say this right here. This is real important. We're going to say if a squared plus b squared is equal to c squared in a triangle, when a and b are your shortest sides, okay? If a squared plus b squared equals c squared, then it's a right triangle. When a and b are your shortest sides and c is your longest side, because the hypotenuse in a right triangle is always the longest side. Maybe go back to this part of your notes. Right here where we called this hypotenuse. Longest side. Really important. The hypotenuse is always the longest side. We're going to say if a squared plus b squared is less than c squared, then we got an obtuse triangle. If the sum of the squares of the two shortest sides are less than the square of the longest side, the triangle is obtuse. And if a squared plus b squared is greater than c squared, then we've got an acute triangle. All right, so in the last part of your assignment today, you're going to be asked to determine whether each set of numbers can be a triangle If so, classify. Here's what that means. If you're given, determine whether each set of numbers can be a triangle. If so, classify. Let's clean that up a little bit. Let's say classify as right, acute, or obtuse. So you're going to get three numbers, 7, 14, 16. The first thing you got to do is determine if the numbers can form a triangle. And you learned earlier in the year that if you had to find the range of values for the third side of a triangle, that the third side of a triangle is between the sum and the difference of the first two sides. So 14 minus 7 is 7, and 14 plus 7 is 21. So this third side is between 7 and 21. So since the third side is between 7 and 21, then this is a triangle. So determine whether each set of numbers can be a triangle. Yes, this can be a triangle. So then we determine, or we find out, we say 7 squared plus 14 squared, and we say, how does it compare to 16 squared? And when we do that comparison, it's going to tell us what kind of a triangle it is. So 7x squared plus 14x squared equals 245. And 16x squared equals 256. So our two shorter sides squared are less than the third side squared. So what kind of triangle is it? Our a squared plus our b squared is less than our c squared. So it's an obtuse triangle. You guys good with that? Let's do 9, 40, and 41. 9, 40, and 41. First of all, is it a triangle? Is the third side between the sum and the difference of the two shorter sides? 40 minus 9 is 31. 40 plus 9 is 49. And the third side is between 31 and 49. So this is yes. And then we take 9 squared plus 40 squared, and we compare it to 41 squared. The sum of the squares of the two shorter sides are equal to the longest side squared. That makes it a right triangle. Fair enough? Any questions on anything we've talked about today? All right, your assignment for today is page 551 and 552. They've been uploaded to the resources tab. You're doing problems 1 through 19. Problems 1 through 19. E-learners, if you don't have any questions, you're excused. Those pages have been uploaded to Focus. Make sure that you check Focus later today for a homework assignment. You guys that are in class, you can go on your phones and access those pages. Or there's some textbooks in the back room, red textbooks. There are some now that have trickled out onto the desks. You're welcome to use those as well. You can also grab one of those textbooks if you like from the back and just take a picture of each page if you would rather do that.